Okay, let's start. Okay, first of all, good afternoon, everyone. Thank you for joining today's Steel Connect webinar with the title of The Evolution of Coated Steel for Modern Resilience Architecture, proudly brought to you by NS Fusco Malaysia. Before we begin, please mute your mic throughout the whole session. Should you have any questions, feel free to post them into the Q&A section together with your email address or your contact number. We'll try our best to address your question at the end of the webinar or follow up with you afterwards. Right, for architects, please remember to complete your LAMP CBD checkout by scanning the QR code at the end of the session. All right. For engineers, please kindly stay until the end of the webinar, complete the survey form to claim your BEM CBD points. Right, I see a bit of chaotics in the check-in, so no worry, all the architects, if you have any difficulties to check in, as stated by my colleagues in the chat box, all right, just screenshot the arrow that you encounter and provide the membership ID and your IC number to my colleagues. We will try our best to help you, or you will receive the e-certificate, and then you maybe can just appeal your case to the LAMP. All right. So without further ado, let's start our today's session. Right. Okay. Today, we are not alone. We are happy to have several guests joining us. They are Encik Muhammad Khazani Omar, Senior Associate of GDB Architects, A.R. Liu Che Seong, the Executive Managing Director of Cipta Teguh Architects, A.R. Lee Ming Zhao, Architect of KH Architect, Miss Katie Chong, the Design Associate of Cipta Teguh Architects, A.R. Chong Lee Seong, Managing Director of LSA Architects, and last but not least, we have A.R. Razin Mohamud, the Principal Architect of Razin Architects. We are truly grateful for their support and willingness to dedicate their valuable time to this webinar. Their insightful contribution through the pre-record interview session have greatly enriched the quality of today's webinar. On behalf of NS Fusco Malaysia, I would like to express our sincere appreciation and heartfelt gratitude for their support, commitment, and contribution to make this webinar a success. Thank you very much. Today's webinar will take us to the fundamental of coated steel technology. We will explore the past, now, and future of coated steel roofing and walling with the valuable insights shared by our guests along the way. Please stay focused on my sharing, as we will be hosting a quiz session at the end where you will be having the chance to win datum tickets. My colleague, Ms. Nicole Ling, will be taking over the quiz section later. So let's begin our journey through the evolution of coated steel. Okay, let's start with the past, the history of coated steel roof. Let's begin by looking back the history of roofing materials. Since the earliest days of civilization, people have used various roofing materials based on their local resources and construction know-how. Over time, roofing materials evolved from natural materials such as stone, reeds, bamboo, palm leaf, etc., to more advanced solutions that offer better strength, durability, water resistance, safety, and aesthetics. This raises an interesting question here, right? Why has roofing material continued to evolve over years, and what drives industry to adopt new technologies? Let's explore this together. Let's take a close look on how roofing materials had evolved over time. In the early days, stone was used due to its strength and durability. We can achieve the protection purpose, like for example, protect from the weather of the animals or beasts or whatever it is. But it had proved that it is very poor in water resistance. Therefore, as societies develop, materials such as the hay and reeds become popular because they were lighter and more water resistant compared to stone. However, they were highly combustible and pose significant fire risk. To overcome this limitation, clay was used either standalone as a tile roof or complementing with hay or reeds. It offers a better water resistance and fire performance, but it makes the roof heavier. So it requires stronger support structures. Later, advance in technology led the adoption of metal roofing, which provide many benefits that cannot achieved by other materials, such as strength, lightweight, water resistant, non-combustible, and ease for installation. Today, tile roof and steel roof remain the two most widely used roofing systems in our construction industry. This evolution shows that how the industry has continuously sought for the better performance, durability, safety, and construction efficiency. Right. However, when did the human first discover the metal can be used on top on the roof? Any idea of that? One of the earliest known example is a building with a metal roof. It's called Loma Hubaya. Also known as the Brazen Palace, it earned its name because the roof was constructed using the bronze house, making it one of the earliest recorded used metal roofing in architectural history. This structure is located in a place called Anuradhapura in Sri Lanka. Sorry, I must admit that the pronunciation is a bit challenging here, so let me play the pronunciation for everyone. Yeah, it's called Anuradhapura, all right? It's in Sri Lanka. So Noma Hubaya is originally built during the time of the power of the king of the name as Dudu Gemunu. It's a bit difficult to pronunciation also. But this king, he built this temple actually is the in the between 161 to 131 BC. All right, the effort to promote Buddhism in Sri Lanka. So beyond the historical significance, it is also a remarkable example of the Asian engineering and architecture. Imagine that more than 2,000 years ago, people were already exploring the use of metal as a roofing material. If you find this building interesting, I encourage you to explore more detail in the internet. Right. So how did the Kuta steel become widely used for roofing or wall cladding in the modern world today? Right. By late of 19th century, galvanizing technology had become widely adopted. The construction industry soon recognized that Kuta steel as an ideal material for roofing and walling due to its strength, durability, lightweight, water resistant, and non-combustible. In the early years, roofing sheets were produced in short lengths because it's roll formed horizontally, as shown in this photo. Right, require multiple laps that increase the risk of the water leakage. That's due to the limitation of technology. No choice, you only can do that during the time. As industrial buildings such as factories and warehouses grew in the size in the Industrial Revolution, the demand for the faster construction and long length roof increased. To meet this need, the industry developed long length roll forming technology, allowing the roofing sheets to be manufactured in much longer lengths with a fewer joints and lower water leakage. This innovation was so successful that the long length roll forming remained the standard manufacturing method for Kuta steel roofing and wall cladding system in today's world. Right, we have explored the history and evolution of Kuta steel roofing and wall. Now let's hear from our guests as they share their experience with Kuta steel, the benefit of using high quality materials, and the challenges associated with the low quality products. I believe their real world experience will provide a valuable insight to all of us. So without further delay, let's hear from our guests.
My first project using coated steel was a gun house. Can you believe it? It was a gun house. Some people call it gun house. I call it an entrance statement. It's the first thing that you will see when you approach any development. You know, so we needed something to, you know, span. A long span because we need to allow for dual carriageway underneath it. So of course, steel is the answer. We use steel structure, and on top of it, we put steel coated steel roof. And another reason why we use coated steel was that we needed something that will last through time. I do not want to face any complaint from the developer or even the residents that it leaks and so on and so forth. So yeah, I'm indeed very happy on the decision to choose coated steel for that structure.
Hypermarket back in 2011. Tight budget, tight schedule. Coated steel was a pragmatic call. Fast to install, low structure loading, cost effective, of course, low maintenance. The client wasn't asking for an architecture ambitions, but rather what we stay with us is how much the color choices that matter to them. And that was the first signal that surface finishes was not incidental. It was doing real identity works. Good materials solve multi-problems simultaneously. And that project showed me coated steel could move beyond the industry into January architectural.
In Malaysia, is
In
it?
Malaysia.
Okay. Well, of course, I first used coated steel in when I was practice, both as a student in my student projects and in Australia when I started working. Coated steel was more like the default material whenever you want to use steel decking or steel cladding. It's on coated steel is like default. You don't use anything less than coated steel. Right. So of course, when I came back to Malaysia, the first introduction of coated steel was in a bungalow that I first designed. The owner really wanted tile roofs, and I said no. Can we try coated steel? And I said why? I said well, first is the appearance of the building. I think it just suits the building a little bit better, easier installation. And hey, you know, I know a lot about insulation that I learned from Australia now, and coated steel will last practically forever in that sense, and we wanted to do a particular roof that will not be able to be achieved with conventional roof tiles. Yeah, so that was the first introduction of coated steel. Yeah.
I'll say a school sport facility building in Bentong about 8 years ago. High humidity environment, so corrosion resistance was a top priority from the start. We specify a high quality AZEC coated steel with a low gloss finish, and the building has held up exceptionally well. No complaint from the school, no revisit for warranty issue, and I appreciate most is that the color retention has been consistent. The building still look intentional, not weather or forgotten.
Let me take my own first project as an example. So it's the Penang Island Waste Transfer Station that was completed about 8 years ago. So up to now, I think the colors of the coated steel color bond, they have not quite faded. And mind you, it's just next to the sea. Okay. So our clients, they occasionally organize educational tours for schools. And these visitors, they would love to take photos in front of a particular color of the color bond, which is the color bond sunflower gold. They really like it. And we also conducted a site visit in recent years for our architects and peers in the industry. The cladding that encapsulates the building form is still intact. So I think when coated steel is being installed properly, it is rather maintenance free and it is self-cleansing. Definitely a peace of mind for the building owners and us as architects.
I suppose we, of course, coming back to Malaysia, when we had the opportunity to use coated steel, or rather, I should say, when we required steel decking or steel cladding, we would have used coated steel, even in Malaysia. But I suppose the project that encompasses the most complete usage of coated steel, and also a project that we have some pride in terms of how we configure it together, was a factory that we built recently in Selangor. It was a production factory, and the requirements of the factory, due to the thermal comfort, natural thermal comfort, and the basically the configuration of the factory, dictated that coated steel would have been the best material that we use. Right, so we did that, and it wasn't just a single detail. While the finishing coated steel is one element, how it's put together in terms of whether it's a roof, whether it's the wall, whether it's a cladding facing heat, the morning sun or afternoon sun and all that, the way with which we put it together differed, and it was very specific for the performance expected of that wall. Yeah, but the primary material was coated steel. So yeah, that project was very illuminating for us. But thankfully, none of my projects suffered any ill consequences when I use coated steel. Yes, but I have seen a lot of applications of what appeared to be coated steel, or they use coated steel but the wrong materials to support the coated steel. For example, they use GI for gutters, GI for flashings and all that. In conjunction with coated steel, then we see the effects of the cathodic corrosion, how rapidly the corrosion, if you use the improper materials matched with coated steel, so those are consequences. But of course, those things we learn from the very first day when I was in university in Australia, because the Australians are very, very proud of the coated steel technology. So that was sort of ingrained in us right from those days. So yes, thankfully, I have not experienced any ill effects or any bad consequences from the use of coated steel in my own projects.
The worst nightmare is color fading and rapid corrosion during installation of the facade.
From an architecture standpoint, material failure affecting more than appearance. It compromises the overall user experience, the building quality, the building value, and the public perception of quality. The direct replacement cost may be significant, but the reputation damage is what the industry under-discuss. This is why we always advocate evaluating material based on life cycle performance rather than initial purchasing price.
Steel in general will not last because of the nature of the material. It will rust when it's exposed to the element. So it has to be treated well. So as architect, we need to make sure that we specify the right kind of coated steel that will last through the time of duration of the project that is intended to last. There are cases where colors will fade and we have leakages in building because rusty steel roof. So it is very important to make sure that you choose the right material from the very first day.
First of all, thank you to all the guests for sharing their valuable insights, experience, and perspective. Sometimes selecting a lower cost, lower quality coated steel product may help achieve a certain short-term objective, such as meeting the tight budget, right? However, when viewed from a long-term perspective, it is rarely a winning decision for all the stakeholders. The building owner may eventually bear the consequence through premature deterioration of the roofing system, resulting in higher repair or maintenance costs over the building life cycle. For consultants, such as architects, engineers, or even QS, or as well as the developers, the impact can be even greater. A reputation built over many years can be affected by the issue arising from a roof. Therefore, when a roofing system underperforms, the consequences are often shared by many parties, but the benefits selecting lower quality products are typically enjoyed by only one party, which is a supplier or manufacturer of their products. So in short, choosing low quality coated steel may create a short-term gain for a few, but in the long run, this is a loss for building owners, project teams, and the industrial reputation as a whole. So nobody truly wins. Right. So we have completed our journey through the past. So now let's move to present, which is now. So let's begin our journey into the present and discover how coated steel technology had evolved over the years and coming to today's. Before we talk about the present, let's take a quick step back and take a look on how coated steel technology has evolved. Understanding its history will help us appreciate more of the today's technology. The journey began in the mid-18th century, when concept of protecting steel or the protecting iron by dipping into the molten metal was first introduced at the French Royal Academy. After that, in the early 19th century, the English physicist and chemist called Michael Faraday discovered the principle of sacrificial protection, where a more active metal, such as zinc, sacrifices itself to protect the least active metal, such as steel, from corrosion. Building on this discovery, hot dip galvanizing technology became widely adopted during the late 19th century, particularly throughout the Industrial Revolution. Following this widespread commercialization of hot dip galvanized steel, the construction industry quickly recognized that the benefits and began adopting it extensively for roof and wall application. In the early 20th century, John Lysak introduced the coated steel sheeting to Australia, and the technology gradually spread throughout the Asia-Pacific region. However, innovation did not stop there. As research and material science continued to advance, scientists developed a better and advanced coating technology in the early 1970s by combining aluminum and zinc. This new technology, known as aluminum zinc or AZ coating, deliver enhanced corrosion resistance and improve overall performance compared to the traditional zinc coating. Today, several coating technologies are available in the market, such as zinc, aluminum zinc, or even zinc aluminum coating. When AZ or Z or even ZA coated steel technologies have been widely adopted in the construction industry, their initial applications are broadly used in industrial sector. They were extensively used for factories, warehouses, and other industrial buildings, where the fast construction, durability, and low tolerance for the water leakage were the main requirement for the projects. But how about now? Is coated steel roof and wall is still limited to the industrial segment? Okay, now let's hear from our guests and learn from their observation in the industry. Do they see increasing trend in adopting coated steel in the building design compared to the past, and why?
Definitely, and it's happening across segments that wouldn't have considered it before. Commercial, educational, and even residential projects are now specifying coated steel for facades. Two drivers: cost pressure and a genuine leap in finish quality. What's available today, it's a different category from 15 years ago. Climate change is also shifting the conversation. Clients are asking harder questions about material durability as weather events become more extreme, and coated steels answer those questions well. The aesthetic stigma has largely gone. Modern finish, colors, and profiles have helped move the material beyond purely functional application into a mainstream architectural design.
Oh yeah, there's still is very much acceptable throughout all kinds of projects now. It used to be just for roof on factories. I think I still remember 20, maybe 25 years ago, we were not allowed to use any steel roof on housing project because it's considered, low quality material. But time has changed. We don't use coated steel roof just on roof now. We also use coated steel for cladding to be a wall material, and it's becoming quite popular because of the performance of the material.
Okay, so in the past, we see a lot of coated steel being used in industrial buildings, but now the coated steel trend, they have shifted towards commercial, institutional, and even residential. I think it's because of the durability, the improved corrosion resistance, and the versatility of the coated steel that we as architects or designers, we can shape it into any form that we wish.
Right. So thank you for our guests for sharing their valuable insights and perspective. Today, coated steel roof and wall is widely used across residential, commercial, institutional, and infrastructure projects. The reason is very simple. Because coated steel offer a combination of advantage that many traditional building material may not able to match. For example, high strength and security provide a reliable structural performance. Lightweight construction, this is thanks to the thin gauge steel design which reduce the structural cost and structural load. Cost effectiveness and higher productivity as installation is faster and more efficient. Aesthetic flexibility with a wide range of colors, the finishes, and profiles available to suit different architectural design. Robust and excellent durability, offering strong corrosion resistance and long-term color retention. Superior water resistance, particularly when installed using a long-length roof sheet that minimize the joints and lap connection. And finally, steel is non-combustible, make it a safer building materials. We have discussed the most common coating technologies such as zinc and aluminum zinc, right? But did you know that there are several other coating technologies available in the market and not all of them deliver the same level of protection or the performance? Let's hear from our guests and learn from their perspective on this topic.
Yes, I'm aware of different performance for each of the coating, because to meet of the different demand, different typology, different areas, different location of each architecture. So each of the coating will perform different.
Yeah, to be honest, I'm still learning about these 5 main coated steel technologies, and I would love to keep on working with the BlueScope team to learn more about that, to specify the correct thing. Okay, of course, these various coating technologies, they will not perform the same because they are coated and tailored differently to suit different and specific sites and projects.
You know, there are various metallic coating technologies available in the market right now. So, as designers, we are aware of such movement, and it is very important for us to understand that. So, like I said, you need to choose a company or manufacturer that will provide you the technical support in guiding you or helping you in selecting the best material, the best treatment for your project.
No, not at all. And assuming they do is where specification error happens, and all of them sits on a meaningful performance spectrum. And AM is the most advanced currently available, and in aggressive environments, the gap between coating types is the difference between a material that holds and the material that starts degrading within a few years. And specifying by coating category alone is not sufficient either. Manufacturer and production standards matter, and that's a due diligence conversation architects need to be having with clients and contractors, but not just leaving it to procurement.
Yes, there are 5 main metallic coating technologies available in market today, which is Z, AZ, ZA, ZM, and AM. Each offer different level of corrosion protection and performance. In terms of development, zinc or Z is the oldest technology, followed by AZ and ZA, while ZM and AM represent the latest generation of coating technologies. A simple way to differentiate them is by looking at the first letter of the alphabet in the destination. For A family, which is starting with the A, all right, in the destination, is a aluminium rich coating, which is AZ and AM. Whereas when you see Z in front, we call it as a Z family, which is zinc rich coating. Think of them as 2 different families. While all are designed to protect steel, they use different coating chemistries and therefore deliver different level of performance. Among them, as mentioned by just now, architect Katie Chong is mentioning that AM, aluminum zinc magnesium, is the latest coating technology and is increasingly recognized as a premium solution for roofing and walling application due to its superior corrosion resistance and durability. Today, the most commonly used coating technologies for roofing and walling in Malaysia are still zinc and aluminum zinc, which is Z and AZ. But have you ever wondered that, are they really the same? Or can one simply just replace for the other just like that, right? Right, before we compare Z and AZ coating technology, let's take a step back and understand why technology continues to evolve and why newer technologies are always replace the older one. Let's use Mini Cooper as an example here, right? On the left-hand side is the original Morris Mini Minor. Commonly we call it as a classic Mini. The first introduced in 1959. It is two-door and four-seat small car. Whereas on the right-hand side is a Mini Cooper S, launched around the millennium, all right? At its core, it is still two doors and four-seat small car. Two models separate by about more than 40 years. Can we say, are they the same? All right, maybe some of you say yes, maybe some of you say no, right? Yes, because both cars are designed with the same purpose, which is for transportation, right? But no is because the newer model has evolved to meet the changing market demands and customer expectation. For example, the tires are getting larger or more robust to support the high speed and modern road condition. And the wiper, all right, the wiper, as you can compare the old one and the new one, has improved to provide a better performance under today's weather condition. And the overall design has evolved to match the modern aesthetic preference, such as if you have a eagle eye that you can see that in the old model, you see the door hinge there, right? The door hinge found in the classic Mini have been disappeared in the newer model. And of course, the engine performance, the horsepower have been significantly enhanced to meet the demand of the modern driving. The key lesson learned here is, as customer expectation, the environmental condition, and the performance requirement change, the product must also improve to stay relevant and competitive, right? The same principle applies to the coating technologies. The evolution from Z to SZ and later newer technologies is driven by the industrial need for better performance, durability, and efficiency. All right, so now after the explanation I just shared just now about the Mini Cooper, do you still think that zinc and aluminum zinc coating are same in terms of performance and their ability to meet today's market requirements? If your answer is still yes, so let me just leave you the three questions here, right? If Z and SZ are truly the same, can just replace by each other, why was the new coating technologies developed, right? Why would companies and manufacturers invest millions of dollars in research and development to create a new technology, right? If let's say the new technology was created just only for the marketing gimmicks designed to charge customer higher, why they're still widely adopted and accepted by the market today, right? The reality is that technology evolved to address the new challenges and changing requirements. SZ coating was developed because the market demand longer service life for better corrosion protection and greater flexibility to support modern architecture and building design. In other words, SZ was not just created to replace Z without any reason. By the late 19th centuries, zinc coating technology had become widely adopted around the world. Then about 60 years later, aluminum zinc SZ coating technology was introduced as the next generation in metallic coating technology. One visible difference in between two different coatings is their spangle appearance, which reflects what? Reflects that different coating composition and manufacturing process is appear in between two technology. More importantly is the protection mechanism is different. With zinc coating, protection relies mainly on zinc sacrificial action. Therefore, a relative thicker coating is required to protect steel for corrosion in a long-term basis. In contrast, SZ coating combines the benefit of both aluminum and zinc. Aluminum provides barrier protection, while zinc provides sacrificial protection. Because of this double protection mechanism, SZ can deliver superior corrosion resistance with a thinner coating. But it still raises the question here, right? Why was there a need to evolve from zinc to SZ? Right? Why did the industry require better corrosion protection than the traditional zinc coating that could provide? To answer that, we may need to look at the environmental condition have changed over time. If you follow the latest climate studies, right, the global warming is no longer a future concern. It is happening today. According to the World Meteorology Organization, WMO, 2024 was recorded as the warmest year on record, with global average temperature approximately 1.55 degrees Celsius above the pre-industrial level. With the recent heat wave that struck the Europe and United States and many parts in the world, we can see that the frequency and intensity of extreme weather events are increasing. So at this point, maybe some of you may be still wondering, why does the warming climate have to do with the coated steel technology? To answer this, it lies on the moisture. As a general rule, for every 1 degree Celsius increase in temperature, the atmosphere increase approximately 7% of the water vapor or moisture. Think of atmosphere as a giant sponge. The warmer it becomes, the more moisture it can absorb and retain in the atmosphere. This means that as global temperature rise, the amount of moisture in the air also increases, creating more aggressive environment for corrosion. This is why today's roofing and walling material face more demanding environmental conditions than they did decades ago, and why industry continue to seek for the higher performing coated steel technologies to improve the durability and service life. As corrosion risk increase, the demand for higher performing coating technologies increasing as well. All right, now let's take a look at the demand of new coating technologies from design perspective. Just take a look at these 3 old photos in this slide. So what did you notice in common? All right, as you can see, right, actually all the buildings are used corrugated steel roofing and walling with exposed fastener system. At that time, building owners and designers were mainly focused on the functionality, durability, and cost effectiveness rather than aesthetics. As a result, corrugated profiles with exposed fastener were widely accepted and were considered one of the most modern roofing solutions at that era. However, as architecture evolved, and so did the demand expectation, designers begin demanding cleaner aesthetics, concealed fixing system, and more complex roof and wall profiles. To achieve this modern design, coated steel must undergo sharper bends and more complex forming process. These requirements are rarely considered when zinc coating technology was first introduced, as roofing systems at that time were mainly simple corrugated profile with gender bands. This changing design trend became one of the key drivers behind the development of newer coating technologies. As building design become more complex, coating technology also have to evolve. Modern roof and wall profile require sharper bands and more complex forming processes, placing greater demands on metallic coating. A thinner coating helps reduce the risk of cracking, peeling, and delamination of the metallic coating during the fabrication. In summary, the evolution from Z to SZ coating technology was driven by 2 key needs: better corrosion resistance for today's more demanding environments, and greater flexibility to support modern architectural design. With this enhanced protection, improved formability, SZ coating not only deliver longer service life, but also enable architects and designers create more flexible and complex appealing roofing and walling system. Of course, the evolution from Z to SZ is only part of the story. When selecting right coated steel for roofing walling application, there are many other important factors that designer and specifier need to consider, such as durability, aesthetic, environmental condition, project requirements, and life cycle performance, etc., etc. So let's hear from our guests and learn what factors they consider when selecting coated steel for their projects.
All right. Well, from a functionality, we'll say that the coated steel, whichever material we choose, if it's a coated steel, it's really got that base functionality or the base quality in terms of its resilience to corrosion, its lightweightness, and the fact that they can come with great spans to avoid lappings. And we are so familiar now with how to do the associated mounting accessories, flashings, gutters, etc., etc. So I will say that is a given. In terms of how we actually specify, I suppose nowadays you'll just come to what colors are available, what you can do. but more precisely, what kind of seams that can be created, because I was mentioning parametric design. So when you do parametric design, you go away from the common row seams, which is coming back to how long it spans, etc., etc. So that one will require understanding on how the manufacturing process can be utilized to create our designs. Yeah, so be looking at far greater involvement with the manufacturers, with the fabricators, on how to interpret our architectural design in order to create the appropriate pieces for the use of a coated steel. The color fastness will be quite an important thing. If I understand that color technology has improved by leaps and bounds now, so there are certain colors that we know is not very durable in terms of UV under the UV sunlight. So yes, that would be quite important. Yeah, if we have a particular color selected, yeah, if the people who are doing the formulation of the color of the coating can give us some assurance on the longevity of that the color against fading.
Well, the conversation has moved beyond just price per square meter. Corrosion resistance, thermal performance, solar reflectance, maintenance requirements, and environmental impact. These are now standard specification variables, not afterthoughts. And SRI values in particular have become a serious discussion in Malaysia because of the urban heat island concerns, especially on large roof projects. And the spec has to account for all this upfront, and retrofitting it later is where the projects gets expensive.
We need to ensure that we select the type of coated steel that comes with strong technical backing. I mean, as designers, we may not know everything about the material, so we need a strong backing. We need strong technical support from the manufacturer side to ensure that we do get the right material for our project. You got to think about budget constraints. It has to match our cost plan, and it has to perform well in some harsh area like coastal area. So as designers, we have to make sure that we select the material that is fit for its purpose.
All right. Thank you to our guests for sharing their valuable insight. So we discussed about the factor of selection of the steel today. Then how about the future? So now let's get ourselves into the future and see what may be happening for the demand of the coated steel in the future. Right. So now let's take a look at the future. Maybe you can say that it's from the manufacturer perspective or maybe from the general perspective of how the coated steel demand or the changes or the factors that maybe factors the designer or the architects or the consultant to choose the materials. All right, even the building owners or the contractors. All right, let's start with the material in demands. All right. So sorry to go back to this. All right. Okay, as discussed earlier, global warming is an ongoing challenge and we must be prepared for the future. As environmental conditions become more demanding, the need for more durable and higher performance building materials will be continue to grow. All right, in the past, designers and building owners mainly look for the coated steel that could provide reliable protection against weather. At the time, zinc coating technology was good enough to meet the requirement. And today, designer and building owner recognize the need for the higher performing materials to cope the increasingly challenging weather condition. This is one of the key reasons why aluminum zinc coating technology was developed to provide enhanced corrosion resistance and longer service life. Then what about the future? As extreme weather events may become more frequent and extreme, the demand for even higher performing coating technologies will continue to grow. To tackle the future challenges, the next generation coating technologies, such as AM, aluminum zinc magnesium coating, may become an important solution due to their superior corrosion resistance and durability for roof and wall. However, what makes the next generation coated steel technology different from AirZ? AirZ provides double protection through the aluminium barrier protection and the zinc sacrificial protection. So in general, we call it as a two protection phases. AM makes it a step further by incorporating magnesium compound, creating 4 protection phases and delivering even stronger corrosion resistance, especially in the demanding environment. What even more impressive is AM achieve higher performance with a thinner metallic coating than the conventional AirZ coating. In short, AM is the next generation of coated steel technology of protection, greater durability, and enhanced performance of the future building needs. Look ahead, what will be the future of the on-site inspection and the verification of coated steel roofing and walling system on-site? In the past, material selection was relatively simple, as building owners, consultants often pay less attention to the detail of the coated steel products. Today, situation is very different. Stakeholders like all of you today are more knowledgeable and demand for the transparency, including verification of a product's origin, specification, and authenticity. As expectation for quality assurance continue to rise, traceability and product verification have become more important than ever. That request is usually quite easy to accommodate because most reputable coated steel manufacturers print a branding text on the reverse side of the steel sheet. As long as the roofing sheet has not yet installed or underside remains accessible after installation, the branding text can be checked to verify the material's origin, specification, and authenticity. However, the construction industry is moving faster than ever, and today's projects demand for the quick decision. As a result, consultants and building owners may no longer be satisfied with waiting for the document or checking the reverse side of the roofing sheet. Instead, they may expect a quickest way to verify the material's origin and authenticity on site. So how can we meet this demand? Let's explore the next generation of traceability solution. One example is introducing of UV branding text on the surface of the steel sheet. When a UV light is shined onto the surface, the branding text becomes visible, revealing the product traceability information so that the contractor, building owner, and even consultant will know the specification of the projects. But once the UV light is removed, the branding text becomes invisible again. This helps builders to provide immediate verification work on site, giving consultants, building owners, greater confidence that the specified products has been supplied and installed. And more importantly, it helps to protect all stakeholders from the risk of fake materials entering to the site. Some of you may be thinking that, that's a great idea, right? But it sounds a little bit futuristic. Well, let's take a look how this technology become reality. What you're seeing here is an actual footage captured on site. The UV branding text technology may be new to the coated steel technology or construction industry today, but it representing what? It representing the direction in which industry is heading with using the fast and reliable on-site verification method. Lastly, how about the sustainability trend affect your way in selecting the right coated steel for roof and wall application? Today, sustainability, ESG goal, or green building initiative are familiar concepts to most of us. However, if you look back a few decades, they were not common in construction industry. A major turning point actually came in 2015 when United Nations adopted 17 Sustainable Development Goals, in short SDGs, with climate action identified as one of the key global priorities. Then 1 year later, 2016, recognizing the growing urgency of climate change, the Paris Agreement came into force, bringing together the 198 parties committed to addressing the issue. As a result, government, businesses, industrial stakeholders take significant steps to reduce the greenhouse gas or GHG emission to improve the sustainability performance. This is why factors such as solar reflectance index (SRI) of roofing materials and the U value of roofing system have become increasingly important in the building design today. In short, construction industry today is no longer focused solely on the durability and performance. It is also about sustainability, energy efficiency, and supporting the broader ESG objective. Then what about the future? Looking ahead, countries likely to adopt more aggressive measures to reduce GHG emission, and carbon taxation could become one of the key driver of change. As a result, consultants, developers, building owners, and contractors will need to be more selective when choosing construction materials and suppliers. Manufacturers that provide environmental product declaration, in short, you call it as a EPDs, will have an advantage as EPDs offer transparent and verified environmental data throughout the product's life cycle. By using product with EPDs, project teams can more easily assess GHG emission and prepare for future carbon-related regulation. In short, future material selection will not only about performance and cost, but it will be also about sustainability and carbon accountability. All right, that's all for my sharing today. I hope you enjoyed it. So now it's time for the most exciting part of today's webinar to all of you, because I think you're waiting quite long for that. It's a quiz time, so good luck to all of you. So Nicole, over to you.